Hey, and welcome gurus to this lesson, Azure Load Balancing Concepts. I'm Chase, one of your Azure training architects here at A Cloud Guru, a Pluralsight company, and it's in this lesson that we're going to start off learning about all the basic concepts that surround Azure Load Balancing, and that's going to look like first describing what load balancing is, and then talking about the types of load balancing that exist. And once we've done that, we'll jump into the components that are involved in load balancing. We'll talk about the types of rules that exist for load balancers, and then we're going to take a look under the hood of a load balancer so that we can understand exactly what is going on. And then we'll wrap up this lesson with some key takeaways. So without further ado, let's get started. Load balancing is this idea of distributing traffic evenly across a workload, specifically a workload that's running in the back end. Now, just to help us get an understanding of exactly what this looks like, let's take a look at a virtual network here. In this virtual network, we have a subnet, and we have a public IP address that our client is going to request from. And this is going to send that traffic into our virtual network, our private network space, and it might be mapped to one of these virtual machines we see here. Well, if we wanted to distribute this traffic, right now, our current solution would require that we have multiple public IP addresses for each one of these virtual machines, because we don't have a way of making sure that the traffic distributes evenly in just this setup here. And what we can do is we can actually put a load balancer in place and remove the public IP association from that resource and actually associate the public IP with a load balancing solution so that whenever the client makes a request, they're requesting the public IP of the load balancer, and the load balancer is intelligent enough to be able to distribute this traffic evenly across the workload. Even as we get new requests from new clients, we can distribute this traffic to make sure that traffic gets distributed evenly, and this is going to provide us a highly available solution because we are always going to have something available to distribute traffic to. Now in this example, what we've done is create what's called an external load balancer, but with load balancers, we can have both internal and external load balancers. With internal, we have just the private IP, and with external, we have the private IP and external IP, and these are comprised of a front-end configuration, much like we have for resources like a virtual machine where we have a NIC and a front-end configuration for that. We'll have a front-end configuration for the load balancing solution. This allows us to be able to have a front-end to reach those resources that are in the back-end pool, in this case, those virtual machines. And that load balancer is able to control traffic with rules that we create on that load balancer. And it's also able to then determine health checking to see if these resources are healthy so that it can properly distribute traffic to the backend load, providing us, again, that high availability. Now, at this point, we've described load balancing as a whole and exactly what goes into it and what purpose it serves. We're going to dive a little bit deeper here now into talking about the types of load balancing. We talked about internal and external. And with internal, we have private IP address. The front-end IP is a private IP only, and it's balancing for resources that are needed only internally. And when I say internally, I mean privately inside of our network. So just that private IP traffic inside of our virtual network in our previous example. And this only allows us to have outbound connectivity to the internet, right? We don't have the inbound connectivity from the internet because this is an internal load balancing solution when we use internal load balancers. With external, we have the opposite. We have a public IP address, and in the front end IP, we have a public IP. Again, there's still a private IP configuration to be able to NAT that traffic, but the main idea here is that we're balancing for resources that are needed externally. And we have outbound connectivity to the internet as well. So we have the ability to connect inbound and outbound from external places like the internet and not just in the private IP traffic of our virtual network. Now, while this covers the high-level differences between internal and external load balancers, I think it's easier to understand all of this when we actually look at it inside of a diagram instead of just comparing in this versus one another chart here. So let's take a look at the solution in a diagram and understand the differences between internal and external load balancing. Let's say we have our virtual network. And in our virtual network, we have that subnet that has VMs inside of it, right? And let's say we have an external load balancer. And what this really means is this has a public IP address it's reachable from the internet. So our clients will be able to reach out to a public IP address and request traffic to be balanced between the backend pool of resources for this external load balancer. And this could be something like a web server. Now, let's talk about what we would see for an internal load balancer. Let's say these web servers use a database. As is common with most web applications, we have a database layer. So in this database layer, we have more virtual machines. And maybe we use an internal load balancer so that we can balance traffic between these database VMs. And what we're balancing traffic for is actually these web server VMs that are running in the back end of the external load balancer. And so these VMs will reach out to the database using the private IP address of the internal load balancer, and this internal load balancer will balance that traffic to those database VMs running in its backend pool. And this is the difference between external and internal load balancers. You see here, we have the purpose of providing external resource access, and then with internal load balancers, we have internal resource access. Now let's get into the components that are involved in actually making this load balancing happen. In our example here, we have our VNet with our subnet, and the very first component is our front-end IP configuration. This can be a private or public endpoint, as we've seen with internal and external load balancing solutions. And then we have in the backend pool that workload that is behind the load balancer, where we're actually balancing and distributing requests to our resources. And then we have a health probe that is performing that periodic check to determine the health of those resources in the backend pool, and it's seeing if they're available to serve traffic so that this load balancer can, in an intelligent way, make sure that traffic finds a place that is actually capable of serving it. And then all of this is happening because rules that we have. We have load balancing rules that are allowing us to distribute this traffic evenly. Now, with our load balancing solution, we have other types of rules besides just the load balancing rules that are balancing traffic between those resources in our backend pool. We also have DNAT rules that allow us to NAT traffic that is inbound for our resources, and we have outbound rules that allow us to configure how traffic flows outbound to places like the internet. And we're going to get into more details on how that looks in just a second. But first, we need to address something: session persistence. When we have clients requesting for resources from a load balancing solution, how do we make sure that they are stuck with the same resource serving their traffic throughout their entire session? Well, we do this using the front end and the back end of our resources. And what is happening here is they're accessing the front end and it's dishing that traffic back into the back end pool. And it's making sure that we get the source IP and the destination IP, the source port and the destination port, and the protocol for which they're communicating over, and keeping this in something known as a 5-tuple hash, as we're familiar with when we talked about our network security groups in a previous section. And we're using this information to establish that stickiness, that session persistence that allows us to say, hey, this client is accessing this resource. So we know we want to keep this session open. We want to make sure that they are stuck to this resource throughout the entire session that they have, and establishing that session persistence. Now that we understand how we can make sure that clients end up establishing stickiness with the resources running in our backend pool, let's actually dive into talking about the types of rules that we have for load balancing. So again, like we said, we have first DNAT rules. And DNAT rules take that source IP, right, our client IP, and the request to the destination IP and port, for example, the public IP of our load balancer and port 22, and then we NAT that from public traffic to private traffic and send that to a private IP and port in our backend pool. And we might use DNAT rules for something like making an SSH connection into a resource in our backend pool. And then the next type of rule we have are those load balancing rules. Those load balancing rules are the ones that are actually dishing out our traffic. It takes that front end port and protocol and that back end pool port and protocol and ensures that traffic finds its way to the appropriate resources in the back end pool and distributes that traffic evenly. And this is where we establish that session persistence we were just talking about by having that 5-tuple hash of mapping the front end IP and port to the back end IP and port and the protocol by which they're communicating. For example, they're communicating over TCP for HTTP traffic over port 80 from the front end to the back end. And then we have, finally, our last rule type, which is our outbound rules. These are our source NAT rules. Think of these as the opposite of DNAT. We're talking about going from a source IP, which could be the private IP of a virtual machine, getting that out to a destination IP and port, which could be the public IP of our load balancing solution, and then sending that out to an IP and port somewhere else. For example, a IP and port out on the internet, requesting some sort of traffic from maybe a resource we have running on premise. Now, these are the rule types we have with our load balancing solution, and it can seem as though it's very difficult to understand what is actually happening in this load balancing to make all this magic happen to be able to determine where traffic should go inbound and outbound and balancing between backend pools. But we're going to make it a little bit more simple by taking a look at what's actually going on under the hood here. So we have our resources, right, in our virtual network, our virtual machines, and we have our load balancing solution with a public IP address. And our client makes a request to that load balancing solution. And that load balancing solution determines where it's going to distribute that traffic in the backend pool. And then it returns this traffic directly back to the client. It doesn't even go through the load balancing solution. It just sends it straight back to the client here. Now, this is happening via that source NAT. It's just sending it right back because the default is to just send it straight back to the client. Under the hood, what's happening here is the client's making a request to a gateway. And this gateway has a route, and this route goes off to one of our MUXs. And this MUX here is able to make a decision on where it needs to send this traffic in the backend pool. And it sends it to maybe one of the virtual machines that's running on a physical host, like host 2. And then that virtual machine is able to respond to the client directly. This is called direct server return. Now, this is what's going on under the hood here. It's multiple solutions that are abstracted away from us that are running on Azure and presented to us as a load balancing solution. Now, let's make our way into talking about some key takeaways of load balancing here. For this lesson, if you take away anything, the things you need to take away are that the purpose of load balancing is to distribute traffic evenly across those resources inside of our backend pool. And this is to provide high availability to our solutions so that we always have something available to service requests to our resources. And this all takes place using various types of load balancing. We have those internal load balancers for serving private traffic, as we saw with our database diagram. And then we have those external, which we saw with our web server diagram, where we were providing access to internal and external resources and balancing that traffic. And the components that are making this possible are those front-end IP configurations, be those private or public, the back-end pool, which are the resources doing the actual work, and the rules that are providing the logic on how to distribute that traffic between those resources in the back-end pool whenever traffic comes in from the front-end IP and gets mapped to the back-end pool. And then we're also checking these resources using a health probe to determine whether or not they're healthy and able to service our traffic. And for our load balancers, we have various rule types, those DNAT and outbound rules that control how traffic is coming inbound and outbound. But also, we have those load balancing rules that determine how we balance traffic between those resources in a backend pool. All right, gurus, that is all my time for now. Thanks so much for joining me in this lesson, and I look forward to seeing you in the next lesson.